Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the math portion of GRE. We have been solving math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 151. Turn to page 151, and the problem is on the very top of the page. The exact same problem also appears in the old GRE book, which is right here. I'm holding in my hand, Practicing to Take the GRE General Test, the 10th edition, which is based on the older design of the GRE. But the same exact problem appears in your book here in the revised GRE. There are some questions that they have reused, and this is one of them. When this question was given, 53% of the people got it right. About half the people had trouble with it. Let's see what it has. We are given a picture here that looks something like this. We have a circle here. So right, I guess. Let's put a center here just for our convenience, even though the picture itself does not give us a center, but we're putting it for our own convenience. And here's a quadrilateral. Again, this dotted line in the circle, we're putting it for our convenience here. The question simply is, what's the area of the quadrilateral? A, B, C, D. Well, in order to find out the area of this quadrilateral, there are a couple of ways you can do that. One way is to actually break it up into two halves like we just did here. A, B, C is one triangle and A, C, D is the other triangle. The area of triangle ABC is simply 1/2 base, which is A to C, times height. 1/2 base, let's call it A to C, times height, which is from here to here. Let's give it a name here. We have A, B, C, D, let's call it E. So B to E. B to E is the height of that triangle. That's how high the triangle is. This is the base. I'm using this as the base. You can use any of the sides that you can use BC as the base, but then you will have trouble figuring out the height. This is the easiest scenario. So 1/2 base, which is A to C, which we are told is 10. The problem tells us that the diameter is 10. It says in the problem that the diameter of this circle is 10. So that was the easy part. What about B to E? How much is B to E? To which the answer would be, how the hell do I know? Because we don't know where B is located. We do not know where B is located. And what I mean by that is this. Okay, I need the room here. I'm breaking. I can feel it. I'm getting this uncontrollable urge right now to break into a sermon. And before I start my sermon, I need the room. We do not know what B to E is because we don't know where B exactly is located. The pictures on the GRE are not drawn to scale. For example, let me give you a silly example just to drive the point home. If I ask you which building is taller, building A or building B, you cannot just point to the bloody picture and tell me that of course building B is taller, I can see it. No, you cannot see it because I have not told you anything about A and B. There has to be some information, a mathematical information, which helps you ascertain the exact height of A and B before you can sit there and claim that B is taller than A. Maybe this one, maybe from here to here, maybe this is from here to here is 100 meters. And maybe from here to here is 100 feet. In which case A would be taller because it's drawn on a different scale, it looks shorter. B is drawn on a different scale. How do you know that the scales were same? They are not drawn to scale. Pictures on the GRE are not drawn to scale. Another way of saying the same exact thing, the more polite way, the more straightforward way of saying the same exact thing is what you see is not what you are getting. You must analyze it. You cannot just depend on your eyes. Another scenario where B might be located, the way they give you, is the way I try to draw it here. Another place where B might have been located is this one right here. B could have been located here. Like this. Let's call it D1 and D2, and B1 and B2. Or they could have been located here. Let's see if I can find a different color, a blue color. This is your center here. This is the center from here to here. B could have been located here. This is the third scenario. And by third scenario, I don't mean there are only 3 scenarios. There are infinite possibilities. We do not know where B and D are located. If B actually happens to be located here at B3, then the distance from here to here would have been exactly 5, because I'm showing you that it goes through a center. So what is the maximum area? So the answer is here. Because we do not know where B is located, we cannot figure out the height of the triangle B to E. We cannot figure it out. And because we cannot figure out the height, we do not know what this quantity is. We have no idea what this quantity is. And therefore, the answer is D. Therefore, the answer is D. I'm going to erase all of this thing here because it's getting too crowded. And I'm going to ask you a new question. Okay, pay attention. What if instead of 40, we had 50 here? If we had 50 here, what would have been the answer? Analyze it and tell me. Pause the video, analyze it and tell me. Instead of 40, if we had 50, what would have been the answer? Well, 50 is this scenario. Watch here. We know that from here to here is 10, which is what I'm calling A to C. This is our center. This would be the scenario of the area of this so-called quadrilateral being 50. Now I refer to it as so-called because when this happens, this quadrilateral is just a generic term. It's a generic term which simply means a four-sided picture. A square is a very special quadrilateral. So this quadrilateral degenerates, if that's the word you want to use here, metamorphoses into a square. Let's see if we learn any of these words. Metamorphose. If not, we need to put it on our list. In case you're curious right now what I'm talking about, in addition to the math videos, I have vocabulary videos on the YouTube in case you want to improve your vocabulary. And metamorphosis is not here. I'm going to put it on in the future. I'm going to make a note to myself. Anyway, so here, if this point B happens to be here, and if this point D, instead of being way up there, it happens to be here, then B to D is 10, and A to C is 10. In which case, the area of this quadrilateral would be 100, not. It will be 1/2 from here to here. Let's call this center O. From B to O is 5, and from O to D is 5. So 1/2 base B to D, or rather A to C, same as here. Height 1/2 base times height. The base is A to C. I'm using. A to C is what we used for the base before. The height would be B to O. 1/2 A to C. A to C is 10. B to O would be 5. 50, half of 50. And then again we have this triangle which also has half of 50. So the maximum area that this quadrilateral is going to have when B and D happens to draw a line which goes exactly through the center is 50. That's the maximum area this quadrilateral is going to have. but we do not know if it actually does have maximum height, a maximum area. So even in this case, the answer would be D. Now here's the next question. What if instead of 50 in this column we had 60? If we had 60 in the second column, now that we know that the maximum area that this quadrilateral can have is 50, that's when B falls here and D falls here, and they draw a line that goes through the center, and it turns into a nice quadrilateral, a nice square, that is, in which case the area is 50. Right here it is. I don't want to erase any of that. It will be a nice square, in which case the area, maximum area that it can have is 50, because this is 60. Even if it did have maximum area of 50, it can never be more than 50. Because this is more than 50, the answer in this case would be B. But in the previous two scenarios, the answer would be D, because we do not know where point B and point D are located. It could be very skinny, it could be very fat. But even if it were fat, which is fattest scenario would be where it degenerates into a square, even in that case the area of that thing will be 50. It will be less than 60. The answer is B. That's all. Okay. I'll talk to you tomorrow on day number 40. Bye now.